Hello class, this is a video tutorial on the power rule. Differentiation by first principles can be used to find derivatives, but there are shortcut rules we use instead. The very first rule that we use is called the power rule. So given a function f of x equals ax to the power of n, its derivative f prime of x is equal to a times n x to the power of 1 less the power of n. So I'll take you straight through the first 6 examples for this. It's rather straightforward. So if we have f of x equals 2x, f prime of x is equal to, we bring the power to the front. So this is 2 times 1, giving us 2x. We subtract this by 1. So 2 minus 1 is just 1, which we don't need to write. So the derivative of x squared is 2x, and there's the shortcut. Second example, g prime of x. We take the power, we multiply it by the coefficient, so that's 3 times 2, giving us 6x, and we subtract this by 1. So 3 minus 1 is 2. So the derivative of 2x cubed is 6x squared. The derivative of h of x is h prime of x. And even with negative values such as this, it'll be 4 times negative 5. So it's negative 20x cubed. And that's how we find the derivatives. So let's keep going. If there are multiple expressions just separated by a sum or a difference, it's just individual applications of the power rule to each of these expressions. So p prime of x is going to give us 6x squared. So taking the power, 2 times 3 is 6, 3 minus 1 is 2. So that's just the derivative of this first term. It's a plus, so it's going to be plus 2 times 3, once again, is 6x, because it's 2 take away 1, so it's going to be x to the power of 1. And where possible, you should always factorize where you see it. So this will give us x plus 1. So the derivative of this expression is 6x outside of x plus 1. Let's keep going here. The derivative of q is q prime of x. This first expression, very straightforward. It'll be 8x. 2 times 4 is 8. 2 minus 1 is x to the power of 1. Now for this one, even if we follow the same rule, take a look at what happens. 1 goes to the front, so it'll be 1x to the power of 0. But x to the power of 0 is just 1. So this is really 1 times 1, which we can simplify and write as 8x plus 1. So in short, you can go from here straight to the derivative. A shortcut for this is wherever you see a single x term with a power of 1, whatever the coefficient is, that is its derivative. And for the last one, r of x, r prime of x. And here's that rule again. X is to the power of 1. Whatever the coefficient is, that becomes the derivative. And for this one, think of this as x to the power of 0. 0 times 3 is 0, so we don't need to worry about the rest. So the derivative of this expression is just negative 4. I'd also like for you to remember that this is a linear function, y equals mx plus c, And notice that the gradient of this function is -4. So even when we apply the power rule to linear functions, it comes right back into full circle to what we initially learned. All right, so hope to see you in the next video where we do the next set of examples. Hope to see you then. Best of luck.